Welcome back. We are going to be doing one more of those double unit conversions, and then we'll move on to pressure conversions. Now, for the double unit conversion, again, it may be a unit you're not familiar with. We're coming back to that mole. And I hope you're at least getting an inkling that a mole of anything is equal to 6.022 times 10 to the 23rd. Now, if you're not really wrapping your mind around that in terms of the science, it's okay. I'm using it explicitly as more and more examples so that your mind will be a little bit more familiar with it when we get to that point in the notes. So I have to do two things here. I've got 2.178 times 10 to the minus 19th joules. That's how much energy it's going to take to break one bond. That's what that double unit means. And the question asks us to figure out how many kilojoules it would take to break a whole mole of bonds, or 1.022 times 10 to the 23rd. So that's our goal. Now, there's two parts to this. One part is going to be to take bonds to moles. The other is joules to kilojoules. And again, it doesn't matter the order that you do for that. So let's go ahead and start our grid. 1.178 times 10 to the minus 19th joules for every one bond. Now, I like to get rid of the one in the denominator first. I'm not sure why I do this, but it just seems to be easier for me. That's in the denominator, so to eliminate it, I need to go up to the numerator. That'll cancel. And I want to convert bonds to a mole of bonds. And my conversion factor says that for every 1 mole, so I'm going to put the 1 in front of the mole, I have 6.022 times 10 to the 23rd bonds. So if I stopped, I'd have joules per mole. But it asked me to take it one step further and get to kilojoules. So I've got joules now in the numerator. To eliminate it, I'm going to put it in the denominator and put kilojoules in the numerator. Find your prefix. That's a 1. 1 times 10 to the 3rd joules for every 1 kilojoule. Now my joules cancel. And when I'm all done with my math, I'll have kilojoules left per mole. And if you do that math, we get 131.2 kilojoules per mole. Don't forget to include your units in your answer, and don't forget to go back and check sig figs. My original number had 4, so my final number has to have 4 sig figs in it. Now I want to move on to pressure. The conversions for pressure is simply another dimensional analysis. Unlike temperature, which was an adding and subtracting of a factor, we're going to do dimensional analysis for pressure. Pressure is a measure of the force exerted per unit area. And we have two types of tools that measure pressure. A barometer measures the pressure of the atmosphere. We have a barometer in the back of the room by that back door. And when you hear the weather guys talk about, or gals talk about barometric pressure, that's what they're talking about, because we're measuring the pressure in the atmosphere and we use a barometer for that. If we're talking about an experimental type of a value, we use a manometer. So that's learning at the definition level. So I want you to be familiar with those two vocab words. They're more likely to be in your multiple choice since there's simple definition at that point. Now, unfortunately, there's way too many conversion factors for pressure. I really wish we would stick to our SI of pascals, and really more conveniently is kilopascals, because we tend to be more in that range of pressures, certainly at our level. But the industry still uses many others. The industry is going to use an atmosphere. That's going to be defined as the pressure at sea level. I like it because it's a 1, which makes our mathematics easier, but I think it can be a little bit frustrating for me, at least, because I don't think it's the most physically meaningful of the units. Another unit is called a millimeter of mercury, and that was developed when they used to look at the height of a column of mercury. So this would be mercury. Mercury is used because it has a high density. So you don't need a very long column because it's not going to move very far in response to pressures. So you would have had a pool of mercury here. A reason we don't use this anymore, of course, because we don't like to have pools of mercury sitting around the classroom. And the atmospheric pressure, for example, would push down on the pool of mercury. That would force the mercury up the tube, and we would measure that in millimeters of mercury. Now, the dead guy who really developed this is a guy named Torricelli, so it's also called a torr. Now, notice that when you're going from millimeters of mercury to torr, you can simply just exchange the units. There's no conversion. They're equal to one another. So if you don't like millimeters of mercury, just cross it off and put torr, however you like to work with that. Now, all of these are equal to 1 atmosphere, so then they're all equal to one another as well. Now, you are given these conversion factors on your formula chart, so you don't need to memorize them, although memorizing means you can work faster. So in the first problem, we've got 1.55 atmospheres is equal to how many kilopascals? This is identical to what we've been doing all along. So if you want to pause the video right now and try it on your own first, that would be a good idea. I'm going to go ahead and start this. It's a one-step conversion because I have a conversion from atmospheres directly to kilopascals. It's not a double unit, fortunately, so we're going back to something fairly simple. Or, at least basic. If it's not simple to you, don't feel bad. We'll get there. I'll help you. Atmospheres, opposite to cancel. I want kilopascals. I strongly encourage you to put in units before you worry about numbers. Now we can go over to these numbers. There's a 1 in front of the atmosphere, so I'll put a 1 there. And there's a 101.33. Sometimes you'll see it as 101.32 kilopascals. If I do that math, and I need to do it to 3 sig figs, because my original has 3 sig figs, and we assume conversions are exact, or we are not going to really go by their conversions or their sig figs. We're going to get 157 kilopascals. And it will be quite common to have to change pressure units. For example, in the United States, in the semiconductor industry, the equipment tends to be in torr. And overseas, say in Japan or Europe, their equipment tends to be in kilopascals. So if you want to compare data, we'll need to be doing some pressure conversions there. Now let's try one more of these before we end the video. We're taking 121.45 kilopascals. We want to know how many torr it is. Now you may think that you need to go through atmospheres, but we can do this in one step. We don't have to go through the atmosphere the way we've memorized these. So I'm going to start with my given, and it's going to be a one-step problem. I have 121.45 kilopascals. I want to get rid of kilopascals, and I want to go to torr. Now, since these are all equivalent to one another, once I've, look at this line of equivalency, I can put a 760 torr, and then in front of the kilopascal, I'm going to put that 101.33 kilopascals. Double check I set it up for my units to cancel. And I know it looks kind of funky because on a typical conversion, you're used to one of them being the number 1, but it doesn't have to be as long as it's an equivalency. If we tried to memorize a different conversion for each of these units, paired between each of these units, it'd be way too many. This way we can just look at a line and memorize a line or use the line of conversions, and it's a lot simpler. And once you do that mathematics, we're going to have 910.90 torr. And again, 5 sig figs there, so 5 sig figs here. Now, those are your pressure conversions. In our next video, we'll start working with density.